this question we are asked to find out the area of the region satisfying both the inequalities rounded off to the closest integer. Now the second equation is quite easy, the second inequality. X square plus y square is less than or equal to 49. The equation x square plus y square is equal to 49 is the equation of a circle. The equation of a circle looks something like this: x minus a whole square plus y minus b whole square is equal to r square. This is the equation of a circle with center at a comma b and radius equal to r. So in this particular case, when you are told that x square plus y square is equal to 49, the center of the circle is origin, which is 0, 0, and the radius is square root of 49, which is 7. Let us first look at the first inequality, which is modulus of y minus x is less than or equal to modulus of y plus x. So let us draw the y-axis and the x-axis. It will look something like this. And let us draw the lines x is equal to y, that is x minus y is equal to 0, and x plus y is equal to 0. The equation of the line x minus y is equal to 0 will look something like this. And the equation of the line x plus y is equal to 0 will look something like this. This is x plus y is equal to 0. This is y minus x is equal to 0. All the points which are above y minus x is equal to 0 will have y minus x to be greater than 0. And all the points below y minus x is equal to 0 form the part of y minus x is less than 0. Similarly, all the points above x plus y is equal to 0 are part of the inequality x plus y is greater than 0. And all the points which are below x plus y is equal to 0 are part of the interval x plus y is less than 0. Once you have this clear, we have to make separate cases. The first case is when y minus x is less than 0, or we'll go with the positive case first. The first case is when y minus x is greater than 0 and y plus x is greater than 0. In this case, the inequality becomes equal to y minus x is less than or equal to y plus x, or the value of y has to be less than or equal to 0. So we are looking at the three intervals. Y minus x has to be greater than or equal to 0. So it will be this side of the line. Then y plus x is greater than or equal to 0. So it will be this part of the line. And we also want y to be less than or equal to 0. Sorry, this won't be y will be less than or equal to 0. This will be x is greater than or equal to 0. This is just simply solving the inequality. So if you are considering the first case where y minus x is greater than or equal to 0, y plus x is greater than or equal to 0, the modulus of y minus x is equal to y minus x, the modulus of y plus x is equal to y plus x. So the given inequality will become equal to y minus x is less than or equal to y plus x, which is x is greater than or equal to 0. So in the first case, we want y minus x to be greater than or equal to 0, so it is this part of the interval. Then y plus x is greater than or equal to 0, so again this is this side of the line, and we want x to be greater than or equal to 0. All three are satisfied in this part of the region. Let us look at the second case. The second case is when y minus x is greater than or equal to 0 and y plus x is less than or equal to 0. In this particular case, modulus of y minus x is y minus x. This has to be less than or equal to modulus of y plus x is minus x minus y. This would imply that y has to be less than or equal to 0. So now you want y minus x to be greater than or equal to 0. So it is this part of the interval. We want y plus x to be less than or equal to 0. So it is this part of the interval. And we want y to be less than or equal to 0. So it will be this region. Let us look at the next case. The next case is when y minus x is less than or equal to 0 and y plus x is greater than or equal to 0. Then modulus of y minus x will become equal to x minus y. This is less than or equal to y plus x. Or here we want y to be greater than or equal to 0. The interval, the range or the region where y minus x is less than or equal to 0 will be this side of the line. And y plus x is greater than or equal to 0, so it is this part of the line. And we want y to be greater than or equal to 0, so it will be this region. So the entire first quadrant is part of the given inequality. Now we look at the last case. In the last case, we want y minus x to be less than or equal to 0 and y plus x to also be less than or equal to 0. Now the given inequality will be simplified to equal x minus y is less than or equal to minus x minus y. Or you want x to be less than or equal to 0. Y minus x is less than or equal to 0 will be this side of the line, and y plus x is less than or equal to 0 will be this side of the line, and x is less than or equal to 0. All three will be satisfied only here. So the entire third quadrant is also part of the given inequality. Essentially, if you are drawing modulus of y minus x is less than or equal to modulus of y plus x, you are going to get the entire first quadrant and the entire third quadrant, and you will get nothing in the second or the fourth quadrant. So essentially, the overall region will be, you draw a circle, the radius of the circle is 7 units, and you will have exactly 2 quarters of the circle as part of the required region, or half of the area of the circle will be part of the region and half of the area of the circle will not be part of the region. So the overall area of the region will be pi r square, which is the area of the circle divided by 2. What is the radius of the circle? We have figured out that the radius of the circle is 7 units. So the required region's area will be 22 by 7 into 7 into 7 whole divided by 2. This is equal to 11 into 7, which is 77 square units.